Indrajit, can we start?
Yes,
Hello. Indrajit, can we
yes, yes.
start now?
You can start.
Yeah,
You
yeah.
can.
Yeah. So, guys, Academy of Data, we have two branches. One is in Bangalore, which is near to Manita Tech Park, near to the HBR level. The other one is in Hyderabad, which is near to JNU Metro Station. So we have two branches, and we have both online and offline programs, guys. So till now, we have been trying more than 2,200 students on the data engineering program, which is like AWS data engineering and the Azure data engineering. Out of 1,200, like we have 70%, 75% of success ratio. And out of 1,200, like 75% of people are already working in different companies with both product and service-based companies. And most of them is also working in abroad too, with US, UK, Ireland, Germany. And we are the official partner for Databricks company. So we are the only persons in Bangalore who is going to train you on the Databricks part, especially in Azure data engineering. And yeah, the coming to the data engineering, we have two different programs. One is Azure data engineering, and the other one is AWS data engineering. Now, when it comes to Azure data engineering, it is a 3 months of program which is been where we provide both online and offline, both for the freshers and experienced guys. And the classes would be on the weekends. Most of the time, it would be on the weekends. That is like Saturday and Sunday, with 3 hours per day. That would be like Saturday, it would be 3 hours, on Sunday, it would be 3 hours. And every Wednesday, we would also have the doubt sessions. If there is any concerns or the doubts regarding the program, that would be clear. Apart from that, from Monday to Friday, from 10 a.m. to 6 p.m., we would also give you an application access where your all your doubts would be clarified. And for the eligibility to join our program, any degree in engineering, computer science, mathematics can also join us the program. When it comes to BCA, BHRD, BBM, and BCom, yes, if they're very interested and if they're in non-IT, yes, they can also join the program. Now, what are the benefits that if you're going to join out the program? Let's consider like Azure Data Engineering. Azure Data Engineering, the tools would be on Azure Cloud, Apache Spark, Python and SQL as a programming language. Apart from that, you would also be working on ADF, that is Azure Data Factory. The max to max, the program would be for the 3 months. If there is any, I mean, if you're missing out the classes or if there is any delay, then it would be extended for the 1 month, the 1 month of the program. Now, how does the program works? Yes, it is an end-to-end program where all the basics would be covered in the first month. And second month, we would also give you some assignments to work on that. And third month of once the program is completed, you would also be working on real-time projects. We would also be giving you two capstone projects that you'll be working on. And apart from that, we are also giving the best part where as of now in the market, you would see very less people is offering this. It's called as a placement guarantee. Along with the program, the one of the most benefiting what you can expect from is about the placement guarantee that no one in the market is providing this. And for that, we would also have some parameters. We could say some terms and conditions too in that way. So the first thing would be your 95% of attendance on the program. Now let's consider we have the new batch which is going to start on next coming week. That would be for the next another 3 months. So we would definitely see 95% of your attendance on the program. So out of 84 hours of live sessions, at least 75 to 80 hours of sessions that you should have been attended the program. That is one of the basic criteria. Second thing would be your live project. At the end of the program, as I said, there would be a project that would be assigned. And if you have the doubts on the project, yes, we would also help you on that, but you have to complete the project at any cost. So this is the second criteria where we would see for the placement guarantee. Third thing would be the certification. As I said, we are the official and alliance partner for Databricks company. We would also give you the certification at the end of the program once you complete your project, and we would also help you to how to clear the certification. But this is one of the main criteria for the to get the placement guarantee. But For the Databricks certification, it has a high level of demand in the market. You can do your homework on this particular thing, and most of them who are in the program, they know about what actually Databricks do and what is the value for the Databricks certification. If not, please go today and do your homework on the. I would really request or suggest you to do that. Apart from that, I would say even for the Snowflake certification and or the Databricks certification, it has a high level of demand in the market when it comes to the tools, when it comes to the value, when it comes to the CTC. Because why I mentioned the CTC, guys, whatever the people are looking for the programs to upskill, right? End of the day, everyone wants the job, everyone wants the high value domain. Apart from that, everyone wants a good salary. So the benefits, what you're going to get at the end of the program would be your things, whatever I've covered till now. Now, the placements, when it comes to placements, yes, this is the you can see the like four of the guys is in the posture. Like one is in the data east, one is in Bosch, one is working in Mindera, the other one is also working in Mindera. You can see the packages difference. There is like 13 LPA, 20 LPA, 17 LPA, and 15 LPA. Now, all these guys has only a difference of 1 year or 2 years of experience in the domain. So, but when it comes to salary, there is a huge difference. Now, why? Again, see, end of the day, when an interviewer or an the placement recruiter would also see what skills you have along with the I would say the soft skills. Now there are few students I've seen for the last 2 years. People are very good at technical skills, but they are not able to communicate to the interviewer. Now you should also work on these part. But again, if you are going to join for the Academy of Data, we would also work on all these parameters. We would also work you on the interview part. Mock interviews should be taken. If there is any concerns you're facing, yes, we would also be clearing that. All these things would be considering for the placement part. Now, this is the success ratio for the last batch what we have. So you can also go through the, uh, I mean, I would say the comments or the people who have completed the program, whatever they have given us the feedback on the program. You can also go through that. So now the I'm sorry to stop 1 second. Yes, guys. So all these things is about the program. Now, if there is anyone who has the doubts at the end of the program, so I'll again come back. Now I'll be overing head to. I mean, I'll be giving the opportunity to Mr. Venkat, who is our trainer. And the guys, we are going to start the coming batch on coming this Saturday. That would be 27th or 28th of this month, the same month. It would be for the next 3 months. So if there is any person who is looking for the things, whatever I've covered till now, please let me know. And if you have any doubts at the end of the program, we will be more happy to answer the questions. Over to you, Mr. Venkat.
Hey, hello. Hi, everyone. Good afternoon. So I just want to give brief introduction about myself and then start sharing the content which I want to talk over this meeting, right? Basically, I have 13 years of experience building systems around data engineering. So when you say data engineering, it is all about bringing the data from various systems and trying to accommodate the data in a single system and try to provide it for the end users, right? As I was doing this job for the last 13 years, I started using creating data warehouses. I'm talking about in terms of what kind of data management systems I was using. And then I moved towards creating a data lakes. Now I moved towards creating a lakehouse architecture. Throughout this journey, right? So I was working various technologies for you to understand my background, right? I worked in Informatica, Oracle, Informatica Netezza, and then I worked on Cloudera. Then there is AWS Cloud, EMR. I worked on that, and I'm working in Databricks right now. I also worked on Snowflake to build this, architects. So it's a completely data engineering profile, yeah. And we'll be discussing how we can build systems using Databricks over this session, right? Let's start sharing my screen so that you will also try to follow me. Let me do the sharing. One second. Are you able to see my screen? Let's keep it more interactive so that I hear responses from the audience. Padvi, can you confirm? Are you able to see the screen?
Yes.
Yes, Venkat. Yes, yes. Yeah.
Let's keep it interactive. Like, I don't want to be sounding boring. Like let's hear question and answers from the audience as well. That's what I was expecting from this session. So basically, we will be discussing focused in this session on data engineering. Data engineering is, you can, in a one word you want to tell about it, is like you have a data on your hand, you try to extract it from multiple places, right? For an example, it can be a Facebook, right? For an example, it can be an Instagram, right? Those are all data producing systems, right? You need to collect them together, try to transform the data as per your requirement, and try to store it in a system. That's what data engineering basically in a nutshell will do, right? So what you will do with the data, right? Whatever the data you collected it, right? What the companies will do, right? Let's see this graph, whatever you're seeing in this slides, right? So basically, people will try to clean the data if there are any like unwanted things, unwanted. So if a user did not enter a particular field, right? So that means it is missing. So try to clean the data, like missing fields removed, or like trying to compensate with by calculating an average of a missing field, right? Basically, they will do cleaning of the data in the initial stage. Later point of time, what they will try to do is they will try to build reports. So how my users are doing in my platform. For example, if you take Facebook, right? Uh, like they can try to build reports, which are the users are coming into the platform, how long they are staying in the platform, right? Such kind of analytical reports will be created on the data which has been collected, right? And there is also a chance like there will be ad hoc queries. So for an example, reports are something you have to tell upfront what you want. Ad hoc queries are something you want that now because you didn't told it upfront. So you have to write kind of a program to understand what you're looking for. Like maybe if, for an example, I want to see how many users came today. So it has not been pre-programmed, then it will be an ad hoc query. If it's a pre-program, it is something like reports, right? And then they will try to do data exploration, right? So these all black bubbles, right? What it will do, that activities are activities you will do to understand what happened in your platform, right? In your Facebook platform, what happened. So the black dots are something which we will be discussing today. So how people will collect the data and how they cleanse it, how they generate reports, how they run ad hoc queries, how they understand what is happening inside the platform. Later, if you grow up, or if you go up right towards the blue bubbles, so this is like predicting what will happen based upon what happened in the past. So it's kind of predictive analytics, right? So you want to predict what will happen in future. So that's called predictive modeling, right? People will try to do predictive modeling on top of the data which they collected. And prospective analytics. So there is an incident happened. So how you will respond to that particular incident, right? That's something called prescriptive analytics. And they will eventually go towards automatic decision making. So if this thing happens, you have to take this decision, right? So such kind of initiatives the organizations can do. So all this possible because you collect the data and you make utilizing of this data, right? So all this black bubbles is part of data engineering. So which Academy of Data is doing. All these blue bubbles, it's part of machine learning and artificial intelligence, like which CellStrat is doing. So in this demonstration, we are partnering with CellStrat, right? How we can do everything together in Databricks, right? You can do data engineering at the same time. You can do data science also in a single tool. So that was the focus of today's session. Any questions so far? Okay.
Good.
Sorry.
All good, Venkat. Thank you.
Yeah. Let's put technology towards the same graphs which we looked earlier, right? So this is I'm just having a breakpoint here. So left side is what happened and right side is what will happen. So basically, if you want to achieve this one, right, cleansing of data, building reports on your data, running ad hoc queries on your data, and you want to do data exploration, right, how your data looks like in the platform, you build a system, something like data warehouse, right? Data warehouse is a popular system. You could have come across this in your engineering concepts as well. So it's focused, it was there from early 90s, right? Early 1990s onwards, the system were there. So it is focused on structured data, and it is good in order to generate a reports to understand what is happening inside your platform, right? Or inside your organization. So that is, we used to build data warehousing traditionally. But in order to achieve the predictive modeling, prescriptive analytics, automated decision making, these are all part of data science group, right? In order to achieve this, people used to build something called data lake. So data lake is more focused on the solving the big data problem. So that is nothing but if you're getting a large amount of data, how you can process it and store it more efficiently and more elastically. That means how you can scale your machines easily and scale down your machines, right? And the variety of data. So it is also focused on how you can store documents, right? How you can store a PDFs, how you can store a log files, how you can store a CSV. Whereas data warehousing is focused only on structured data. That is nothing but how you can store a CSV or tab separated value. But data lake, it goes across images, it goes across PDF documents, it goes across CSV and all that. That's solving a variety of problem, right? So there are three V's big data brings you. One is velocity, the other one is variety, the other one is volume, right? So volume in the sense, today you are generating large amount of data. So every Facebook click you do, every like button you press on Facebook or Instagram, like messages you do, they are all generating the data, and they are generating the data in very fast manner. So that is like volume, also velocity of the data is also more. So in order to accommodate such kind of data, the organizations start building data lakes. So once you collect your data, right, you can do the predictive modelings, right? Whatever is needed, right? You want to predict how a user will come tomorrow and what kind of actions he will do in the platform tomorrow. You can predict it based upon his actions in the past. So in order to do that, like machine learning or data science capabilities, people started using data lakes. So basically, it will use for artificial intelligence. So what will happen in the future to do that? What happened in the past? They still store the data in data warehousings. So what is the problem with this too is there are those are two different systems, right? You have to move the data from one system to another system. So if you look at this one data warehouse, it's focused on structured data. Like that means it is only accepts a CSV, TSV, whatever has a structure, right? Your Excel sheets and all that. They have structure to it. And they focused on how to provide access to how to create a table on top of your file, how to provide access to a particular table. So the governance and security is focused on table level access controls. So how can I provide access to a table to a person? So that is what they focus on. And if you look at the consumers of the system, who will use these systems, right? Business intelligence, the business people who comes from the organization, in order to understand what is happening in their platforms, in their IT platforms, right? They will try to look at your data, right? So that they are come from business intelligence technology perspective. And the second audience who will be looking into data warehousing is like SQL analytics, like trying to run some kind of ad hoc queries to understand, hey, like for an example, I want to understand how many users logged into Facebook yesterday. So such kind of analytics, these people will do SQL analytics. They try to log into data warehousing system which Facebook created, and they will try to see how many users attended in that, right, in that system. So these are like kind of audience, right? So they will be acting on what happened in the past, right? And what they need is highly reliable system. So that means the data should be clean. so that they can use it and understand what happened in the past. And it is also should be efficient. So whenever they try to request some data from the systems, they should be efficiently able to provide the data to the end users. These are the two criteria the data warehousing consumers need it. When you look at the other side, right, this is again another system. It's called data lake. So it is focused on logs, texts. So these are semi-structured data. So whatever the data you generate in your Facebook, right, most of them are semi-structured data. And you have images in your Facebook, you upload some photo into the Facebook, right? That's a unstructured data. And you upload a video into your Facebook, that's a unstructured data. So data lakes are built to cater the needs of structured, unstructured, and semi-structured. So it is not focused on only one kind of data. It is focused on variety of data, right? And their governance will look like, see, most of them are files, right? Videos and images are files. So their governance will look like, how can I provide access to a file? How can I provide access to a folder? So that's something their governance looks like, data like governance looks like. And if you look at the interested party who wants to understand the data lake, data is data science or ML users, right? The other one is data streaming people. So whoever wants to pull the data in real time, right? So they are also another audience. So what they need is they want all the data in one single system, all of the data in one single system, and easy for them to build a machine learning models and try to share it across the peers. Right? These are these people's responsibilities. Like data lakes. Basically, data lakes will be used by data scientists, whereas data warehouses will be used by data engineers. Right? What is the problem is, these use cases will work with their own requirement. These use cases will work with their own requirements, right? These use cases will have their own governance and security, because they will talk, I need a table level access. These people will talk, I need a file level access, blob level access, right? And these systems are completely two different systems. So it's like managing two different systems for an organization is very difficult. Imagine you have a company, you don't want to build multiple systems, right? You want to build a single system which will cater the needs of all the consumers, right? So that's what we'll see. So what we are telling in the slide, there is no need to have two disparate platforms. So you don't need to maintain a separate data warehouse. You don't need to maintain a separate data lake. What we are telling in this, right? You can build something called Lakehouse. So lake is coming from data lake, and house is coming from data warehouse. So you can build one single system which will cater the needs of data warehousing consumers as well as data lake consumers. So if I go back to the slide, data warehousing consumers are business intelligence, SQL analytics. Data lake consumers are like kind of machine learning, data streaming people. We can bring all of them together into a single platform, right? That's called Lakehouse. So the industry is trying to build data warehouses from 1990s to 2012. From 2012 to 2017, they are building data lakes. Now, I think 2019 onwards, they have started building lake houses. So most of the enterprises are building lake houses today. So where they will have a single system which can cater the needs of data science as well as um, business intelligence, right? Consumers, both. Everybody can be in the same. So let me walk through on this ones, whatever we see here, right? So we'll try to build a reliable data platform to efficiently handle all kind of data. So whether it is structured data, unstructured data, semi-structured data, your system should able to process it and able to store it. That is what your primary requirement of a lakehouse, right? The other requirement is you should have a security and governance for all the data assets, whether it is a table, you are a file, right? Whatever it is, either it's a machine learning object or whether it is a data warehousing object, whatever the technology you pick, right? It should able to provide a kind of access management for any kind of object. That is the second criteria. And the third criteria is you have to cater the needs of ML users, you have to cater the needs of SQL users, you have to cater the needs of BA users and streaming users, right? So how we can do this? In the right side is these are the problem statements. In the left side, whatever you see. In the right side is the solutions or technologies that will provide you to solve these problems, right? So at the storage level, we will use something called data lake, which has the capability to store any kind of data. For governance, we use something called Unity Catalog. This is again the Databricks offering. So it will try to provide governance and security for all the data assets present in your Delta Lake, right? And here we have some data applications to cater the needs of business intelligence people and machine learning people. We'll go through them in the upcoming slides. So far, any questions? I can stop by like kind of 5 seconds or 10 seconds. If you have any questions, like we can interact.
Yeah, hi Venkat.
Yeah.
Yeah, brilliant explanation. Like, I just want to know how this lake house is built, like from warehouse and data lakes, how this data is ingested in lake house.
Yeah, we'll see a demo today, how this is built.
Okay, okay.
Yeah.
Hi Venkat, this is Vinit.
Yeah.
Yeah, I have a doubt like regarding the data lake and delta lake. Is it the same or different thing?
Yeah, Delta Lake is something different. Delta Lake is a kind of a pitch which is introduced by Databricks. So basically, Delta Lake is something which you try to bring whatever the data warehousing needs into Data Lake, right? So that's called Delta Lake. Maybe I will try to go in detail in the upcoming demo. Right? It's a different, completely different.
Sure, sure.
Hey, hi Venkat. This is Bhartish here.
Yeah.
So, I had this doubt. Okay, so you just said that Delta Lake is something that is like also considering the data warehouse as well. So, is the Delta Lake itself the data lake house, or is it a part of the data warehouse? Sorry, lake house.
Okay. So what happens? Delta Lake is kind of a system where it uses a Delta file format. Okay, and a Delta file format is a kind of a popular file format which will provide you couple of things which your data warehousing system requires. For an example, if I talk about data warehousing system, so what it needs is like basically, if you look at traditional data warehousing, it requires something called ACID properties. So let's talk into what is ACID properties. So ACID properties is nothing but atomicity, consistency, isolation, and durability. If you look at those definitions of ACID properties, what it means, like atomicity means like when you're writing a transaction into your data warehouse, like when you're writing a query into your data warehouse in an insert query, either the entire insert query should be completed or it should be rolled back. It should not be a partial event. That's what atomicity says, right? That's an important consideration for data warehouses, right? The other one is consistency. Like either you as a user or me as a user, when you query a table, it will always should show the same results, right? And the other one is isolation. Isolation is when two inserts are running on a table, they should not affect each other. Like the first insert should run in isolation when compared to the second insert, right? And durability, what it means, like when you committed something onto your database, even there is a power outage or something, your system goes down and it comes up, your data should be there. So that's called durability, right? So in order to provide these features, right, these are very important features for business intelligence people, because for an example, you are running a pipeline and there is a business intelligence consumer who is consuming your data. You should not be thrown away from the system saying like there is files still been writing into your table. They should be seeing the files which are already present, like ongoing files should not be there, what you call consideration. So you want to build such kind of systems in data lake, right? That's where you will try to use something called Delta Lake. So Delta Lake is basically, there is a format which supports ACID properties, right? And which are much important when you have a data warehousing, you want to like serve the needs of data warehousing. So when you bring ACID properties into data lake, it's called Delta Lake. Basically, this is, I can give you the best answer for your question.
Yeah, sure. So basically, Delta Lake is like also having ACID properties on top of the unstructured data as well.
Yeah,
So
correct.
that's, yeah, sure. And also it's a part of the whole Lakehouse paradigm here.
Correct.
It's not itself the Lakehouse thing, but it's just a part of the Lakehouse architecture,
Yeah, correct.
overall architecture.
So because
Yeah.
your Lakehouse needs the ACID properties as part of Power BI requirement, and your data science needs the, in order to do generative AI, right? Nowadays, people uses documents. For them, ACID properties is not needed. Like they want a storage which will cater the needs of files and images, right? Both combined, it will become a lakehouse, right? So you need to store, structure any kind of data if you want to store, irrespective of the technology which you uses, right? To store in a single place. So that's where you can say it's a delta lake.
Yeah, sure, that answers. Thank you.
One follow-up question on this one. So is data lake supports the principles of CAP theorem? Is it like, what is there? I mean, you mentioned it's a ACID compliant. And I understand that there is a unstructured data as well, right? Which is basically eventual consistency. So is that CAP principles is kind of supported there, or is it more not CAP principle?
Yeah, so that is a good thing. So we when you look at this data lake, we'll try to build on cloud, right? End of the day, I'm thinking at any point of time you can achieve two things, right? In CAP principle, you cannot achieve the three what is there. My understanding is it is more about infrastructure. We use S3 in AWS to build data lakes. We use blobs to build data lakes in Azure, right? Whatever the principles those cloud systems get applied, the same thing will apply here. So basically, we'll not focus on CAP much because we'll try to solve the data needs here. So when you talk about infrastructure requirements, we rely on cloud. I think they take care of the CAP, if I understand.
Yeah, I think in terms of your, I'm not very sort of experienced on the data lake side, but understanding of any NoSQL database or any database that you have clustering concept or sharding concept, right, where your partitioning comes in place. So that's where the CAP theorem principle says you cannot achieve all three together. You can achieve two of them, right? So that's what I was trying to understand.
Okay.
In the Delta Lake, how it will work, right? Because you said
I think that is.
Shall we keep the question and answers at the end, because you may complete your slides or everything, otherwise it will be confusing.
Yeah, okay.
Yeah, sure.
So let's look at how this platform will work, right? This is like in the left side, we are trying to put pieces here. So Databricks, using Databricks, you can build a Lakehouse platform, right? Basically, you can build this Lakehouse in any kind of cloud. So it can be AWS, Microsoft, or Google. So it will work with all the three major cloud service providers. So on top of that, you will try to have a storage and compute layer, right? So which has reliable and performance. It will give you better performance and it will give you data reliability, right? And on top of that, you will have a governance layer, so which will take care of how you can provide access to the assets which you created, whether it's a files or a tables, right? Any kind of assets which you created. So on top of that, there will be consumers. Databricks Lakehouse platform can cater the requirements of, infra requirements of all the consumers, right? Whether you're coming from data warehousing background or you're coming from data engineering background, you can use this single tool, data streaming or data science and machine learning, you can have everything to be worked on a single tech stack. So what happens, right, for the organizations, this makes them more technology lenient, right? You don't need to use two technologies to build a system which can be used by data engineers as well as data scientists. You can have one single system where you can build everything in one single technology stack. So that's what we are trying to tell here, right? Let's go into an architectural patterns, how it looks like when you implement in an industry, right? How it looks like. So if you look at a data warehousing system, so or a data lake system, you will have kind of a sources who brings the data into your platform, right? If you look at here, the batch data. So this most of the people here, these people are the one who will try to bring that source data into data warehousing kind of system. So another kind of users also I'm trying to showcase here. This is like kind of a guys who try to bring data into data lakes, because streaming data, if you consider as Facebook analytics or whatever it is, IoT data and all, it is coming with high volume and high velocity and high variety of data. So that are the needs of data lakes, right? So I'll try to cater this, whatever the architecture we built in the center, it will try to accommodate both, like batch data as well as streaming data. Okay, when you look at this box, this is focused on data engineering, what kind of activities data engineers can do here. And if you took the top box, this is kind of machine learning, how Databricks can help machine learning users to build their machine learning algorithms based upon the data which was brought by data engineers, right? And you can accommodate these two kind of users into a single technology Databricks, right? And let's look into first data engineering perspective, because I am coming from data engineering background and today's session is mostly on data engineering. And let's look how this data can be moved across the layers. So basically, whenever you want to build a kind of warehousing system, you will try to create layers. So the layer definition will be different for different organizations. So let's take here, we call it a bronze, silver, and gold. These are the three layers we are using it here for now. So bronze layer is try to store the data whichever is coming from the source systems as it is. So that is the definition I am trying to give in this PPT, right? So if you want to get the data from source, you will try to get it as it is and put it in bronze. So why I'm dedicating a layer for that is because if I want to reprocess it, right, I no need to go to source again and ask them provide me the same data what you provide yesterday or day before yesterday, because so if I go back every time, that means I am depending on them to provide me the data. So what I will do is whenever they provide the data, I will try to keep an extra copy inside my layer, so that whenever I need it for reprocessing, I no need to go back to them. I can be within this system and try to get the data. This is basically data engineers do, right? On the one layer, they will try to store the data as it is from the source. The second layer, what happens? They will try to build data modelings, right? Maybe you would have come across entity relationship model, first normalization, second normalization, third normalization in your computer science course as part of your engineering. They will try to arrange the data in a better way and efficient way, so that they can store large amount of data and they can store it for last 10 years, last 20 years, like whatever the needs they have. And the third layer is focused on arranging the data to cater the needs of business intelligence guys. So in the gold layer, basically people used to try to create some models called dimension modeling. So it's nothing but your data should be arranged in a particular way so that whenever you are trying to retrieve the data, it will be retrieved much faster. So basically, they will try to do in this three layers. So in business terminology, how you explain is this layer is as it is from source. This layer is you will try to cleanse it, you try to augment it with business rules, you try to filter it, whichever the unwanted data. This layer, you will try to generate KPIs, whatever is needed for business, right? If a KPI is say like I want to know how many number of users came into my platform yesterday, like count is a KPI, that is a key performance indicator for the business to understand how their organizations are doing on the ground, right? That's what they will focus on. And at the end of the day, if you look at this, right, there should be a data warehousing technology, so which powers the retrieval of this data and provide it to the business intelligence groups. So business intelligence groups will come with visualization tools like Tableau, Power BI, Looker, right? They need to always query the data, whatever is present in your Databricks platform, and this data warehousing block, and it is powered by something called Databricks SQL, right, in Databricks, so which will try to provide you visualizations. So this is the data engineering flow. So you will try to bring the data, you try to put it in multiple layers, and then you will try to use data warehouse kind of system called Databricks SQL and try to visualize the data. With the same data, you can provide the same data to machine learning users also, right? Now the machine learning users has 3 kind of stages in their life cycle. So they have to develop kind of machine learning models, and then they have to manage machine learning models, and they have to deploy machine learning models. And somebody like data apps will use those machine learning models and try to understand what will be the outcome of their model prediction. So the same, right, the inflow, if you look at it, whatever the data engineering built, it can be consumed by machine learning users in Databricks. Databricks will provide interfaces to write Python language. It provides interfaces to write in R language. It has something called machine learning libraries, right? So Spark has machine learning libraries. Those are all the fundamental required for a machine learning guy in order to do his day-to-day development activities. And Spark also provides something called versioning. If they can manage multiple models and multiple versions of a model, right? They can do feature building, right, and model building, right? So everything will be done using Databricks. And you can also have an kind of endpoints that you can build using Databricks, right, for batch and real-time ML deployment. So whenever you want a real-time prediction, right, you can build a model and try to deploy it, and you can send the data, input data, it will try to predict, and it will send an output data in real time. So you are able to cater machine learning also within the same technology. So when you have both users, when you are trying to accommodate both users, so you build something called Lakehouse platform, right? And if you look at here, these are the Databricks technologies that powers in order to build this kind of platform, right? So there is something called governance, like you have a mechanism how to provide access to a table, right? And orchestration is needed. Orchestration is capability is telling like, hey, job should move the data from source system to bronze. Once it is moved from bronze to silver, it needs to move. From silver to gold, it needs to move. So this can be done by using an orchestration capability. So Databricks will provide you services to tell how your job should run, right? And it also provides you CI/CD. So that means Databricks can connect to your GitHub repository. It will allow you to maintain your code, right? And do deployments from one environment to another environment. It will also provide you observability platform, like kind of what is happening inside in your platform. It will try to monitor and try to provide statistics, right? Who is querying what are the services running, and all those things, right? So these are kind of solutions, how these capabilities can be achieved. So governance, you can achieve something called Unity Catalog service in Databricks. Orchestration, you can achieve something called workflow service in Databricks. CI/CD is something you can achieve by using repositories, GitHub repositories. And observability can be achieved using something called Delta Live Tables, right? And these are the kind of problem statements it will try to solve, and these are the solutions it will try to solve. Okay, I'm moving towards next. Unity Catalog. So this is the first service I'm trying to introduce you, and we'll also try to see in the demo how we can use Unity Catalog, right? So basically, it is used to manage accesses for all your data sets. So it can be your warehouses related objects like tables or columns. So Unity Catalog will allow you to provide access to a table to a particular user. And it also has the efficiency to provide fine-grained access controls. That is nothing but if you don't want a user to see a particular column in your table, it has the capability to restrict that particular column not to be visible for the user. If you want user not to see a particular row in a table, Unity Catalog has capability to restrict that row not being visible for your end user. For an example, if you look at an organization, if there is a table like salary table is there, and it also has employee details. For an example, your manager wants you to give he wants you to give the access to the table, like your manager wants to give access to the table to you. So he doesn't want you to look at the salary of your colleagues. He wants you to look at only the employee details, like employee ID or employee name, like which department he works on. But unfortunately, his salary details is also in the same table. So he wants to restrict some columns not to be visible, right? He can able to restrict easily using Unity Catalog. He can hide the salary details and give grant access only to see other columns which are intended to be seen to you. So that's one example of fine-grained access controls, right? So it also has the capability to govern data lakes and files. Like for an example, if you have a file and your manager does not want you to look into that file, so he can manage that access using Unity Catalog. Hey, these are the files. These are the 5 files. This guy should look into it, and the other 5 files he should not able to look into it. So he can achieve that using Unity Catalog, and you can govern dashboards and notebooks also. Like you build a visualization dashboard inside Databricks. He can restrict not you from not seeing the dashboard. He can restrict not look into notebooks which he created. So such kind of capabilities you can build using Unity Catalog. These are all kind of access management. It also provides something called a lineage. Lineage is nothing but, hey, I want to understand if I change a particular column in this particular table, what are the other tables it will get impact. This is a commonly asked scenario. If you look at data warehousing, at one particular point of time, you will be working on enhancements. What is the first question comes as part of enhancement is, hey, I have 10 columns. I need to remove one column from it, or I need to add one column to the table which you already created it. So you need to understand where and all the table is getting used. So you need to do all the changes according to where and all the table is getting used. So that kind of capability lineage will provide. So if you take a table in Unity Catalog, you can track it where and all it's getting used, right? And it also provides you attribute-based access controls. This is something like using attributes on your table, nothing but tags. You can put a tag on your table saying like, okay, this bunch of tables belongs to department 1. This bunch of tables can belongs to department 2. And department 1 should have access to only this bunch of tables. It should not get access to another kind of tables. And if somebody adds into department 1, automatically this first bunch of tables should get access to them. So these things can be achievable in attribute-based controls, and this is also possible using Unity Catalog. And you can also define security policies, like kind of what should be shown and what should not be shown, right? That's what we see that. Table level and column level tags, like to identify the table belongs to so-and-so person, the table belongs to so-and-so department. If anything cost is generating by this table, any cost is generating by this table. So this is the cost center it need to pay. So such kind of tags you can put it on a table or column, right? And you can use you can also Unity Catalog also provide auditing. So whatever happens inside, who queried what table, and who accessed the unaccessed data, everything is logged in auditing. So if somebody deleted a table, somebody dropped a table, somebody deleted records inside the table, everything gets tracked in auditing, so that any mischievous activity will be get tracked, right, in Unity Catalog. Data sharing. So if you want to share the data, right, if you are having a platform in Europe, there is another platform in US, you want to share the data between the regions, because this is across the continent. So you want to share across the continent, that can be done using Unity Catalog. You can share the data, whatever you created in Europe, with the people who are present in US platform, right? That is also possible. And when it look at machine learning, again, it is, you can use it, like I'm going quickly here because I also have a demo to be presented. So you can build model registry, right? So you can have this Delta Lake for reproducibility. So what happens, right? So Delta Lake will provide data versions. So today you have one version of data. Tomorrow you have another version of data, right? And you need to create a model on the previous version. So that capability Delta Lake will provide, because data also will get versioned. So if you change the data 10 times for the last 10 days, right, you can always go back what was the initial data which you built a model, and you can train your model on the initial data itself. Like you can pick what version of data you want. So this is one of the major ask for the data science community. Hey, today you change the data, yesterday you have some other data. I created a model on yesterday's data. Today you change the data, my model is working very weird. So I want this old data what you have yesterday. Earlier we used to tell that data is gone. Now because of Delta Lake, there is something called time travel. You can go back in time and try to reproduce the data which was present yesterday. It's very, very needed requirement from data science community. You can do that using Data Lake reproducibility feature, right? And you also can create an auto ML. So there are a lot of auto ML capabilities. You don't need to write all the machine learning algorithms which are needed, right? You can tell the system you can ask the system what is the best model that can give a accurate prediction for this kind of use cases, and you can use it, right? And the data science community, you will have notebooks. So people who are coming from data science community understands, right? They use heavily Jupyter notebooks. In Databricks also, you'll get the Jupyter notebooks. You can also build dashboards, right? And you can also see like kind of MATLAB related plots, everything in Databricks as well. And like Python and R is a more popular language in data science community, and Java and Scala is a more popular language in data engineering community. So all the 4 languages are supported, right? So that means it is scattering all the needs of data scientists as well as data engineers, right? And data engineering workloads, this is focus on, let's focus on this today because I am coming from data engineering background. So I'll try to talk in terms of data engineering, right? We'll have something called Databricks workflows, which will help you to execute how your job should run, right? And we have something called Delta Live tables. Today we'll not cover this because this is an advanced topic. I don't know, like the audience, if they are already using Databricks, we can cover this, but most of the audience are new to Databricks. I don't want to cover this today. And and the data engineering, how it is easy to build, right? Data lakes using Databricks, right? We can look into these aspects for today. Sorry, are you able to hear me? Hello?
Yes,
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 Venkat.
Venkat, we can hear you.
So let's go into demo use case.
Before that, Venkat, there are some questions. If we can answer them, would be great.
I have only 30 minutes. Can you park it? I will try to.
Yeah, sure.
Once you show the demo.
That works.
Yeah. So let's take a use case, right? So that everybody will understand what we are talking today, right? Let's think about, there is a company who actually rent a bike to go from place A to place B inside a big city, metro kind of city like Bangalore and all that. So we are trying to solve their use cases using Databricks, basically data engineering use cases, right? So what they have with them is a sensor which was plugged inside the bike, and the sensor will try to record what is the location the bike has been going, and what is the climatic conditions around that location, and that details will be sent to a system which was present with us, right? Basically, it will try to get the geographical weather related data, right, to us, and which region has what kind of weather is present. So let's see what are the sensors send the kind of data to us. Like, it will send the date information. So we categorize the date into 4 categories, like winter, spring, summer, and fall. So the 12 months will get split across these 4, right? And we also capture month, right? So what day the bike is present in where, and what is the temperature in that location, right? We'll try to capture the temperature, we'll try to capture the humidity, we'll try to capture the wind speed. Why we are capturing these three things is like tomorrow, if in future somebody comes and request a bike for me to travel from location A to location B, I should able to tell what kind of weather he will be facing in my app, so that he will take a decision whether he need to go from A to B or he need to go from A to C. For an example, in the past, in the same day, last year, there was a wind speed on a particular route. And if you are going against the wind and you need to put a lot of effort in order to ride the bicycle, right? So in that case, the user might not go into that route, he might go into some other route. So if I provide that kind of insights for him, he will try to change his routes according to the needs. For another example is like, if it is too much hot in a particular region last month in the same location, if I am able to provide that data, he will try to decide to go into places where it was less like hotness. So such kind of data will be helpful in my application to tell to the user what kind of decisions they need to make in future. So let's try to provide these insights to the user. 3 insights, 3 KPIs, why I would like to provide to him. So what is the biking conditions across the seasons? That's what I was trying to provide. What is the maximum temperature, maximum humidity, maximum wind speed? And I'll try to provide what is the average, if you consider, right? This is at season level. This is like we divided 4 seasons. That means 3 months combinedly, what will be the maximum temperature, maximum humidity, and maximum wind speed. And the other side, I'll try to capture what is the average temperature, average humidity, and average wind speed for each month. This is much granular. The earlier one was a season. This is like each month. And also I'll try to capture the extreme. What is the maximum temperature, maximum humidity, maximum wind speed? This time it's more granular. Earlier it was across the seasons in the first case. Now I'm trying to capture it across the months. So these are the insights I want to provide it to the end user so that he can take a decision whether he has to take the particular route in order to go right on a bike ride, so that he will understand what are the extreme conditions in that area. So this is a kind of a data architecture which I try to build. So you have a file. We'll try to create a file and we'll try to load it into a table. It's called table 1. And we'll try to provide the insights like maximum temperature, maximum humidity across the season. We'll try to store in a table. The other one is kind of average biking conditions. We'll try to store in another table, and the extreme conditions across the months, we'll try to store it in another table. We'll try to visualize this data, how this data looks like, right? That's what we're gonna do. Let me go back to kind of a workspace where I can share you. 1 second. Let's jump into the practical, how it looks like. I'm trying to stop sharing. I'm trying to reshare it again. Okay. So let me share and I'll show you the Databricks environment, how it looks like. Let you guys know whether you're able to see it or not. Are you guys able to see it? Hello?
Yes,
Yes,
we can.
yes, we can see.
Yeah, this is called Databricks Workspace. I'm using Microsoft Azure. I'm keeping time as a consideration because we have only 24 minutes and I also need to open session for Q&A. I'm not walking through how I set up this, but I just want to highlight what are the key features we have today. Something like I have a folder called demo here for today's purposes. I created 2 notebooks. This is called notebook, right? Like I'm just want to show you how it looks like. And if I open the notebook, there are individual paragraphs which will try to calculate what are the problem statement which I stated there, right? And there is something called here cluster. and we'll try to use this cluster. And these notebooks are interactive notebooks. If you run this, the play button which you have for each paragraphs, it will get executed and it will give you the results, right? Whatever happened. So basically what we are trying to do is we collected all the data, whatever is present in a CSV file, whatever the sensors emitting from the bikes, we collected the data in a CSV file. I will try to show you the data. So I try to here, whatever the language I'm using, it's called Spark. Maybe if you want to know more about it, you can enroll the Academy of Data courses, right? But I just want to show you here some details, whichever I collected it as part of the use cases, right? So we are collecting from the bike, what is the date the ride went in the past, whether it's a holiday, what kind of month, what kind of season. Season is like, again, 1, 2, 3, 4. One starts with summer, winter, fall, and all those, right? And here we are trying to collect some kind of metrics, temperature, right? Humidity, wind speed, right? All those details. So that is the information we collected from the bike in this example, right? We store it in a CSV file. So let's go and try to see what we are trying to solve here. So again, this is a notebook which I'm trying to use it. And here I'm trying to store it in a temporary table. So register temp table is a function we use it to store in a temporary table. And here, this is the table I am trying to create now in Unity catalog. This is, I'm dropping already. If there is a table created already, I'm dropping it. So if I'm trying to recreate it again, so if you look at, I'm trying to create a table. And if you look at catalog, right, you can see the table has been created here. This is Unity catalog. When I say catalog, so Unity catalog is the place where I can store the metadata, where I can store the data, where I can store metadata, where I can manage access, right? And all those details. So now the table is created in Unity catalog. You can look at the sample data, but I need to select the compute. I can show the sample data in the notebook itself. Let's go back to the notebook. So executed how to create a table in Unity catalog. I'm just trying to load the data, whatever present in the bike share, nothing but whatever the data present in the CSV file. I try to load it here. And then now I am trying to solve the first problem statement. So what is the first problem is I need to identify what is the extreme conditions in a given season across the seasons, right? What is the maximum temperature I need to calculate? What is the maximum humidity I need to calculate? And what is the maximum wind speed I need to calculate across the seasons? So what I am doing is I'm trying to write a SQL query here. So maximum temperature, maximum humidity, maximum wind speed. These are all present in the bike share table. Bike share table is the one which I created earlier here, right? And what we're trying to do is I'm trying to do grouping by season, so that this is a SQL kind of language, right? If you're familiarized with SQL, you might be knowing what I am telling here. So it's a group by. So that means it will give the maximum in a particular season, maximum humidity in a particular season, and maximum wind speed. There are 4 seasons, right? So it will give you four season related details. What happens? Let me store this data into another table. That is nothing but you see max climate seasons. So what I'm trying to do is the same query, whatever I am trying to run here, the same query, I took it and you created a new table. You see max climate seasons, and I'm trying to load whatever the data present here to this table. So let's run this one. And if you look at this, the result after executing this one, if you look at the result, these are the results she will get. So it's giving me four rows because there are 4 seasons. This is the maximum temperature in the first season. This is the maximum humidity in the second season. This is the maximum wind speed in the third season, right? Similarly for second and third and fourth. If you look at these numbers, you didn't understand much. Like, like third season is hottest. If you look closely because it's 0.86. But if you build a visualization like this, right, this is possible, very much possible in Databricks. You can clearly tell, like by using picture, right? Picture will tell you more words than the actual wordings. That's what you are seeing here. Here I can tell easily what is more here. Like humidity here is 0.97. Here it is 0.94. So humidity is more in season 4, right? And at the same time, the temperature, wind speed is less in season 3, right? Here it is 0.38. Here it is 0.37. So again, temperature is more in this season, like third season. That might be a summer season, 0.93. So you can build visualizations on the data which you created, right, in Databricks, and you can add them to the dashboards as well. So this is the first problem statement, whatever we are trying to calculate here, the maximum temperature, humidity, and wind speed across the seasons. So I also have another notebook. So you can make your problems created in multiple notebooks. You can arrange it based upon your needs. I'm using the same cluster here. Like I have only one cluster. I'm using the same one. So I'm trying to calculate this time average temperature, average humidity, and wind speed across all months. We have 12 months. So I'll get 12 records this time into the table. So I'm trying to drop the table, which is already present, and trying to recreate it because I want the data to be loaded freshly. And I'm going quick, like after this demo, we can stop. I just want to give how it works, like the feel, right? Not going into much details now because this is a demo. I just want to show you what are the things you can do in Databricks. Here, if you look at the 12 seasons, 12 months across the 4 seasons, that's why you're seeing 12 records. What is the average temperature in first month, average temperature in second month, third month, fourth month, like that? Average humidity, average wind speed. If you look at here, I created a different visualization so that it is easy to understand, right? This is the hottest month. So what we are saying, hottest month is July month. So July month is the hottest month based upon our findings in the past. So this kind of analytics you will do once you know what happened in the past. So that's what I was trying to say. In data engineering, we will try to focus what happens in the past. In data science, we will try to focus what will happen in the future based upon what events happened in the past, right? And the third problem statement we are trying to solve is trying to calculate the maximum temperature, maximum humidity, maximum wind speed. Earlier, we calculated the average across the months. Now we will try to calculate the maximum in each month, right? And so I'm trying to load this data into the table. It's got loaded. And there is a visualization built on top of this. Let me query this one so that it gets refreshed. You can see like month-wise, what is the wind temperature and humidity. Now a business person can, if the end user, if I show graphs like this, he will understand, okay, this is the wind speed, maximum wind speed in a month. Month is like 1, 2, 3. I can translate this 1, 2, 3 to January, February, March, April. And I can translate this into degrees Celsius and Fahrenheit as well, if it is wanted, right? Such kind of visualizations, you can provide it. So this is actually a notebook for development. So actually what happens, we will try to create notebooks. We will try to execute the code once it is working, right? We'll try to build something called workflows, right? So workflows is something here I built it for you, like kind of where you can tell what is the task you need to run. Once this task is completed, what is the second task you need to run? So what I told here to this one is, one second. So this one I told, take the notebook and run it. So this is the notebook I attached to the task, like demo, bike sharing, first notebook, and created a task on top of it and allow it to run, right? There is second task, that is second notebook I attached to it and allowed it to run. So what happens, basically, you will try to create workflows, and in workflows, you will try to create tasks, and you will schedule these workflows on a daily basis. If you want to run the same notebooks on a daily basis with the new kind of data, you can use Databricks workflows to execute them, right? And I can issue run now, so this will run in the backend. So it does not need my interaction. The earlier one is an interactive development kind of notebook, right? And it will run with my click on this play button. But when it comes to workflows, without your interference, if you want to schedule something, you want to go away from the system, you want to schedule something, you can use workflows, you can attach those notebooks and you can run it. So this is now executing in the backend. I can go and see what is happening in the backend. So it's still trying to spin up a cluster, right? So that's what workflows will help you. It will help you to schedule your notebooks. If it needs to run at a particular point of time every day, you can schedule it, and it also can help you what is the order of execution. Right now, I am telling part 1 should execute first, and then part 2 will execute second. So such kind of definitions, you can have it in Databricks workflows. Coming back to the other aspect, I want to show you there are different pricings. So there is, I am going into compute area. So there is something called all-purpose cluster. There is something called job compute. There is something called SQL warehouse, right? This has 3 different use cases in data engineering. So what happens, right? All-purpose clusters, you can use it for development. This is where I used all-purpose cluster. I went here, I go to development, bike sharing. If I want to write a piece of code here, I use this all-purpose cluster. Okay, this is an all-purpose cluster. So how I can say this is an all-purpose cluster? If I go to compute and I see the same cluster name here in the all-purpose compute category, I can use it. So this cluster is a little bit costly. The reason is it will provide you interactive interface. That means it will, you can attach a notebook to this cluster. You can execute it. So basically, this will be used for development purposes. So if you want to run same query again and again, if you want to test same query working again and again, you can use all-purpose cluster. So job compute is something which is used to run in the backend, right? Whenever you want to run a particular job in the backend, so you can use this one. So it is not interactive cluster. So it is runs in the backend. So it is less expensive because they no need to provide you an interface where you will interact with it, right? And there is something called SQL warehouses. This is again important for Power BI kind of applications. If I start this one, right? If I start this one, it will give you instantaneous compute. So you can run the query instantaneously whenever there is a visual. So it already started running it. If I want to query the tables which I created in the all-purpose cluster, I can query them here as well, right? So this is kind of, I can query UC bike share, which I created earlier. So it will give you the results. So these 3 computes will used for different purposes. SQL warehouse compute is used for business intelligence tools to connect to Databricks so that they will get ad hoc queries addressed more efficiently, more faster, right? And all-purpose compute is used for development purposes, and job compute is used to run the jobs as part of your workflows on Databricks. So these 3 computes will have different pricings. I'm not going into the pricings, but what I will do is I will try to share back my slide and walk you through what is the differences between these 3. Let me share my screen again. So basically, this is the tech stack we try to use it in the demo. So we use Databricks workflows for writing the tasks and arrange them, what should run first and what should run next. We'll try to use Databricks notebooks to execute it more interactively. For metadata, we saw the metadata get recorded in the Databricks Unity catalog, right? We saw the tables getting created and all that. Lineage, I will try to show you back again. And we try to use the job clusters for whenever you want to attach a notebook to your workflow, right? We try to use job clusters because it is much cheaper. And we try to use Databricks SQL. So if I go back to this presentation, sorry, this page. So we try to use SQL editor here. And when we query the data got built using all-purpose clusters, but we are querying the data using SQL warehouses. So it is showing us the data. Basically, what is happening in the backend is, right, this is what happens. Let me slide show this. So there are three kinds of computes you use it, but all these three computes will point to the same metadata where the actual table definition will store. And that will point to the same data where actual data is stored. So data is stored in blob, it is stored in delta file format. So you can use job cluster to read this data and you read this metadata. You can also use the all-purpose cluster, you read this metadata and you can also read the actual data. You can use Databricks SQL to read the metadata and actual data. So you created tables using one compute, you can access them using another compute, right? Why we have three different computes is because one is good for development, so interactive purposes, all purpose is good for development. The other one is good for running in a batch mode, right? There is a difference between the pricing, these two, right? For development, it will cost you more. For running in batch, it is cheaper, right? The other one is good for your data warehousing needs. If somebody Power BI comes and asks for your data, this cluster will come in 3 seconds. This cluster will come in 3 minutes. If somebody is looking for the data which runs for 1 minute, if you use this cluster, so it will give you 4 minutes, 3 minutes for coming up the infrastructure and 1 minute for execution. This one will give you 1 minute, 3 seconds, because 3 seconds is for coming up the infrastructure and 1 minute for the execution. So somebody is looking for ad hoc queries, this is good. Basically, visualization, business intelligence teams look for ad hoc queries. In that case, Databricks SQL will be used. Somebody wants to develop, as a data engineer, he wants to develop the initial pipelines, but he wants to know what are the errors he is making. He wants to test it in a locally. So he can use all-purpose cluster there. Once he tested it, once he created a robust ETL pipeline, he can use a job cluster to execute it. So that's how three kind of computes will be used. This is a table, when to use what, because as a Databricks person, you need to know what to use and when to use. This is same, echoing the same thing. All-purpose clusters are used for interactive, iterative kind of use cases. That means where you want to interact with system, it need to give you immediately the results. You can use all-purpose cluster. It's basically for development, model building, in machine learning side. Job clusters are not interactive. Something should run in the backend without your interference, right? You want to schedule those jobs to run every day, midnight, 12 o'clock and all that. For that, they will use it. SQL warehouses, again, it's BI, right? You want to connect from Power BI, Looker, you want to connect from MicroStrategy, any kind of BI tools, you can use SQL warehouses to connect it. So I'm little bit fast here, but I just want to make sure like you got the enough needs. But I'll also try to show you one last thing before handing over to Q&A. So we have 5 minutes. Okay. I think there are some tables we created here, right? I just want to show you the lineage information which we spoke, right? We can also see the lineage in Databricks. This is basically, there is this table called bike share. It is getting used in two other tables called climate underscore month, maximum UC maximum climate months. It is also used in UC average climate months. So you understand if there is any changes you want to do on this table. So by looking at this graph, you will know like you have to do the changes in other two tables also. For an example, if this column you want to understand from where it is coming, so it is tracing back, it is coming from HUM column present in UC bike. So it is getting maximum humidity. For an example, if you want to understand where this column is coming from, so it is coming from humidity again and storing here. This is come wind speed. So this is called lineage. You can able to track it wherever it is coming and wherever it is going, right? This is like tracking at table level. This table is trying to produce two other tables, and it is also tracking at column level, right? This is a column. If I click it, right, the column is coming from MNTH column from your source. So it's called column level lineage. So Databricks will allow you to have this row level lineage and column level lineage also. It will help you to track if you want to do any changes on your tables. I think this is possible in Unity catalog, right? And whatever the details we created, It is stored in Delta file format. I'm not going much into Delta, but if you are interested to know how things work in the back end, you can register to Academy of Data courses, right? But this is like my time. I'm opening up for questions.
Thank you, Venkat. I think it was nice, very informative session. Is this demo kind of somewhere we can access, or is it like more?
I will check with the Prithvi and try to see whether we can share it or not. I will check in offline with my team, right? I cannot tell you right now, but I can. You can provide your details. We can reach back to you.
Sure. Thanks, Venkat. Thanks for a wonderful session.
Any questions? Like I said, like you guys can park it out, but I just want to know if there are any questions. I try to address it here.
There are some questions in the chat.
I have got one question regarding the ML flow integrations and all the ML lifecycle management, including pipelines, right? So I do not see the dashboard. Is it means, separately?
Sorry, I'm not able to hear properly. Are you guys able to hear properly?
Yes, there is some noise.
No.
Manimai, if you can repeat, or you can put it in the chat.
Yeah. So what I meant is that all the ML flow integrations and ML
No,
lifecycle.
Manimai, no, you're not audible. There's a disturbance in the voice. So what you can do is, can you please text in the chat box?
Yeah, sure.
Meanwhile, we'll answer the different questions. So if you can do that, that would be great.
Yeah, this you know, the lineage, can you can you explain that one again, please, a little bit?
Okay. You want me to share my screen?
Yes, please.
The lineage is right. Lineage is important in most of the organizations. What they will ask is, if so business comes and asks, right? Hey, I just want to understand where this data is coming from, right? And I want to understand what is the end-to-end journey of this data in the platform, from where it is coming, who are the consumers of this data, right? And what kind of transformations it undergoing, right? In order to answer this kind of questions, the problem statement is to track the data journey, how it is going and all that. In order to, the solution is you try to capture the lineage. And it comes to lineage, again, you have questions like kind of whether I need to track the table level lineage, or I need to track the column level lineage, or you need to track the transformation level lineage. That is nothing but table level lineage is in the sense, hey, this table is there. This is coming from the source. From this table, it is going to how many other tables. The data is going to how many other tables. If you want to track that, that's called table level lineage. So whatever you're seeing here is right. The first table I created is UC bike share, right? From that table, I try to run a query called which calculates the maximum climate, like maximum temperature, maximum humidity, maximum wind speed. So whatever the data I collected from the bikes, I collected in a file, and I loaded that file into this table, bike share table. From there, I calculated maximum temperature, maximum humidity, maximum wind speed. So, and after calculating it, I created a new table, right? And what Databricks does is, it will go to your notebooks. Whatever the queries you ran, it will understand in which notebook what table is used. If I go back to my notebook here, for an example, if you look at here, so it's automatically understanding it in the backend. Bike sharing, if you look at this one, let me not this one, this one. So it is telling, I wrote a query from UC bike share, try to create UC max climate months, right? So this I never told to Databricks, it just executed this query. So while creating this table, So it says like from which table this is getting sourced. So it tracked in the backend, and based upon this SQL, it created lineage. So if I go to Unity catalog now, so that is what it is showing. Hey, you see bike is feeding to these two tables. How it knows is the kind of SQL statement I executed it. So that's called lineage if you want to understand. And also it will also track which column is getting populated from which table from your source, right? So that is it is calculating automatically. So most of the tools will not give you lineage. You have to build out of the box. Databricks will give you that lineage, so you don't need to build out of the box. It will track all the queries which you are executing. Based upon that, it will try to build the lineage automatically. If you want,
this will be in one database or across databases?
Right now, it is only within Databricks, because across the databases, it also depends upon the kind of the existing. They are not into that space, but whatever happens within Databricks platform, they are able to provide you lineage, what is happening.
So in the master catalog, it will have the data, right? I mean, from there, based on that, it is doing it.
Yeah, correct. It does across the workspaces. So in Databricks, you have something called account. Inside that account, it can have multiple workspaces. Inside that, you can have catalogs, right? Whatever happens within your Databricks account, it can track everything, right? Every table it can track, and it will give you the details using these graphs. These are called lineage graphs. It will give you the details. So it's a very helpful feature for data engineers who wants to do enhancements.
Okay.
Sir, I have one doubt. You are telling that whatever the data we have created in the notebooks, and all, will it get reflected to the lineage? No?
Yeah. So what happens? It will show it here. See? So here it will track at table level lineage. It will track what is the notebook it is part of. It is used. The table is used in two notebooks, bike sharing and bike sharing part 2. It will also show you what are the workflows it is using. These are workflow details. What are the workflows it is showing, right?
Yeah.
And what are the pipelines it is showing? What are the dashboards it's showing? I didn't create any dashboards to it.
Yeah. Like
So,
automatically it will get created in the backend.
Yeah, it creates in the backend. So Databricks will do that for you.
Okay. Sir, you have one more doubt. Like whenever the new data comes into the database, will it get affected to for these lineage graphs and as well as for the visualization as well?
A new data will not affect the lineage. New table introduction, new column introduction will affect the lineage.
Okay.
Because we are not showing the data. We are showing the objects within the Databricks. If you create a new pipeline, it will show in the lineage, right? If you create new dashboard, it will get shown. But the new data we are not showing here.
Okay. Thank you.
I think, Venkat, thank you so much for this wonderful session and wonderful demo. We can take one last question from Manimai. He was trying to ask in voice. So he
Yes.
asked maybe it's a lengthier question.
This question is how to achieve for the ML lifecycle management and ML flow integration.
Yeah.
Okay. So I saw it is being done. I can refer you some materials, but I'm not an ML expert in this. That's why I partnered with Celestra so that we can achieve things together in Databricks. I'm more focused on data engineering. I can give you some kind of documentations if you're interested how these ML models can be developed inside Databricks. Because it's two different personas you can achieve in a single tool, but the mindset for me it's not in data science mindset.
Sure. I think that's about it. If no other final questions, we can conclude here. Audience. All right. Thank you so much, Venkat and Prithvi, for organizing and also sharing your knowledge here. And it was a great session. Thank you, everyone.
Thank you.
Thank you, Drijit. Thanks for calling us. Thank you so much.
Thank you, everyone.